Hey, after today, thank you for the suggestion and feedback. I realized looking through 5.1, I really do need to talk about the notation that's brought up. Not about like sequence, index, X, A sub I, or, so that way A sub 1 means first term, A sub 2 means second term, and so on. But I really need to talk to you about the definitions and the terms that are the notation starting to come out when we talk about something called an epsilon. So there's a definition halfway through the section here, and it's not about like this concept, although that's there. It's more about, it says that a sequence A sub n, and automatically I'm using new notation. So my hope is that at some point we do talk about this in a more formal like class setting. There's a class called Sets and Logic, S-E-T-S. And a set is a collection. So this is really trying to represent A sub 1, A sub 2, A sub 3, etc., all the way out to A sub n, and if it's infinite, it'll even keep going. So we're referring to the set of all indexed items. Well, we're going to say that that converges, so arrows pop up, that this converges to L, some number, some real number. L is this real number notation. Again, there is notation there. I want to start using it. I need to stop. But it says that for all sum in, on out far enough, everything graph of a, let's say it's a converging to zero sequence. Right? Usually that's like an exponential, a decreasing exponential sequence, geometric sequence. An exponential function is geometric, it's a decreasing. There are other words here that I'm going to intentionally try not to use. But epsilon really refers to like some element, some arbitrary height. Right? Here's epsilon, and it could be like 1, it could be 0.1, it can be a real number as long as it'd be 0.000000001, right? It's this idea of limit as n approaches infinity, the distance between. So there's some epsilon, and all of these right here are A1 through A capital N. Really, 4, 1, 2, 3, 4. But there's some capital N, like stop. We're finite. We've gone far enough. And everything from that point on is within an epsilon of our limit. So within an epsilon of our limit. So this idea, this formal idea, really becomes trippy as we move forward. Make sure that I talk about it for the notation continues on the limit of the sequence. We write it this way: the limit n approaches infinity, meaning we're getting an infinite number sequence of A sub n is the limit. It's approaching the limit. But the fact is, we mention epsilon, and to me sends up like, whoa, no, we got to talk. Epsilon is just some random arbitrary height, and as long as we are at some point within epsilon of our limit, within this distance right here, this distance of epsilon, as long as we're within that distance, we have a sequence that converges, and specifically it converges to L. Thanks for watching.